Welcome back, everyone. In this lecture, we're going to see how we can now solve the regression task with the TensorFlow Estimator API. Now, there are lots of other higher-level APIs, such as Keras, the TensorFlow Layers API, TensorFlow Slim, etc., and we're going to cover the most popular ones later on in the miscellaneous section of the course. We'll usually deal with either pure TensorFlow or this Estimator API just here in the beginning to kind of get you slowly ranking up on your TensorFlow skills. But for right now, let's quickly describe how to use the Estimator API. So the TF Estimator API actually has several model types to choose from. I'm going to quickly show you the various options. So here are the estimator types. There's first just the classic linear classifier, and it just constructs a linear classification model. And there's also a linear regressor, which constructs a linear regression model, things that we've seen in the past. Then there's also the densely connected neural network classifier, which constructs a neural network classification model. And then there's also the DNN regressor, which is a densely connected neural network regressor model. So before we had these classic linear classification and linear regression methods. Now we can use neural network classification models. And there's slight differences in how you can use these two, which we'll cover later on when we actually show you the examples. It has to do with the way the feature columns have to be given to this estimator object. And then besides those, there's actually combined versions. So there's DNN linear combined classifier, and it just constructs a neural network and linear combined classification model. And similarly, there's the same thing for the regressor. And you don't have to worry about memorizing these right now. We'll walk you through it very slowly. And again, we'll cover it in more detail in that miscellaneous section. So in general, the format to use these estimator APIs, we do the following. We first define a list of feature columns, and the feature columns, it's actually a special estimator data type. So what you end up doing is you can either define just a general feature column and then pass that into a list, or later on we're going to see that the estimator API actually has a lot of built-in tools to help you deal with things like categorical features and not having to worry about making dummy variables out of them. So you define a list of feature columns. Our typical example right now is going to be really simple. So you're basically just going to see us make that estimator feature columns API call, but later on we'll see more complicated examples and we'll see how the estimator API can really help you with that. So once you have the defined list of feature columns, what you end up doing is you create the estimator model. And then after you do that, you go ahead and create a data input function. And that's just another convenience that the Estimator API has for you. The data input function is basically an input function that either takes in your data as a NumPy array, or there's a separate data input function for pandas data frames. So if you like working with NumPy, you can stick with NumPy. If you prefer pandas, you can stick with pandas. It's just two different calls depending on what kind of format your data is in. Then once you've done that, it almost works like, if you're familiar with scikit-learn, it works like one of their machine learning model objects. So basically, once you have your estimator model and you pass in the feature columns, you call train to train the model. You can call evaluate it to evaluate it against some test data that you already know the labels for. And then you can also separately call predict. So maybe you have some test data that you don't know the correct labels for, and you just want to predict what you think the labels could be. You call the predict method. So you have the train method, evaluate method, and predict method all in the estimator object. So let's go ahead and jump right in. Keep in mind, this is a really simple example, so it may not be the best use case for the Estimator API just because it really only has one feature. Later on, for the other examples of regression and classification that we'll see later on in this section, you'll see that the Estimator API is a lot more useful here. Okay, let's start off by creating that feature columns we were discussing earlier. I'll head over to the notebook now. Feature underscore column, and then dot again. You can see that there's different columns that you can basically apply to. And we're going to show a lot more examples of this in our classification walkthrough or code along. So right now I'm going to kind of wave my hand over this part, but keep in mind we will take a much deeper dive into this feature column. But I'm going to say tf.featureColumn, numeric column, because we do have a numeric column value with x data. And then if you do shift tab here, it needs a key and a shape. So I'll say the key is just the string x, and the shape, remember we just have essentially one dimension here, so we'll just say shape is 1. And then this whole thing needs to go into a list. So we actually just have one feature here. So we have all the feature columns, essentially just a list of a single item here, a single feature column, and it's a numeric column. So kind of keep this in mind for the classification code along. We're going to walk through a realistic example that has many more columns than what we're showing here. Okay, so we have all our feature columns set up. Then we set up our estimator. And to do that, this is basically the main part of the API. You say tf.estimator dot, and then we're going to do a linear regressor. So there's also a linear classifier, and if you actually go back here, you can see that there's various TF estimators. There's also a dense neural network classifier and a dense neural network regressor. We'll talk about those later on, but for right now, we have a simple regressor. So we're going to say tf.estimator.linear regressor, and then we need to tell it where are the feature columns. So it has a parameter called feature columns, and then you pass in that list of feature columns that you created. And again, we're going to see much more complicated examples where we have more than just one feature column. Okay, then you should see kind of a bunch of warnings, blah, 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 but don't worry about that. It's just basically information. So our estimator has been created, and this kind of works basically like a scikit-learn estimator if you've used those before. But I also want to show you how to do the train test split. We've gone over it before, so let's actually implement it now. We'll say from sklearn dot model underscore selection import train test split, and then if we say train test split here, I'm going to do the following. We'll say that xtrain and then xeval or xtest, really depends whatever you want to call it, and then ytrain, and then we have yeval or ytest is equal to train test split, and then I'm going to pass in my x data, and then I'm going to pass in the true values for that. And let's go ahead and say my test size is equal to 0.3, and then let's also give it a random state of 101 in case you kind of want to follow along. Alright, so now I've done my train test split. Let's confirm that by kind of checking these out. So if I take a look at my X training data, whoops, I want to actually print out the shape of this, so let's check this out. Check out the shape. And I have 700,000 points. That makes sense. My training point should be 70% of my data, and 70% of a million is 700,000. Let's go ahead and check the same thing for my xeval. So we'll say xeval shape, and that's 300,000. And you'll see the same things for the ytrain and yeval. Now let's go ahead and set up the estimator inputs. So estimator inputs, it's a little bit of this funky thing, but basically you need to have an input function that kind of acts like your feed dictionary and batch size indicator all at once. So I'm going to show you how to do that right now. You're going to say inputs underscore func. So that's just a variable name. Then you're going to call tf.estimator.inputs. And then right now we're going to be inputting from a NumPy array. So we're going to say NumPy input fn. But if you also hit tab here, you'll notice there's an option for a pandas data frame input. So what's nice about this tf.estimator API, it can take in inputs from both NumPy and pandas. Right now we're dealing with NumPy. In the future, we'll see a code-along example with a pandas data frame. The next step to pass in is basically the x and y. So what we're going to do here is essentially pass in a dictionary here. So remember up here, if we come back, we said that this feature column has this key x. So we're going to pass in the same key x there, and then say x underscore train. So that will be our x data, and then we're also going to use ytrain. And then let's go ahead and give it a batch size. So you can see we're kind of doing all these steps that we did on multiple lines in one single input function with the estimator API. We can say batch size 8 or 4. You can kind of play around with that. And here I'm just going to say a couple more arguments. Number of epochs is equal to none. And then I'm also going to say shuffle is equal to true. All right. So I have my NumPy input function ready to go, and then I'm going to do a really similar thing here. I'm going to copy and paste this, and then I'm going to create two more input functions later on that we're going to use for evaluation. So I'm going to basically rename this to train input func, and then set that equal to the same thing here. Let me zoom in or zoom out one level so we can kind of see a little bit more of all of this. So there's my input function, there's my original one, and now I have one almost the exact copy called train input func, except here I'm going to say that the number of epochs I want it to be trained on is specifically 1000, and I also want to set shuffle equal to false. Okay, there we go. And the reason I have shuffle equals false here for this train is because I'm going to be using this train input function for evaluation against a test input function. So I'm actually going to copy this whole thing again, do Shift Enter, paste it, but instead of being train, it's going to be test. We can also, I guess it's going to be called eval to kind of follow the same naming convention we have earlier. And instead of x train, this will be x eval, and instead of y train, that will be y eval. Okay, perfect. So we have these three input functions. Our first step is to train the estimator. So the way we do that is we say estimator dot train, and then you just pass in the input function that you just created. So we'll say input func. Now for this very first one, we didn't actually specify the number of epochs or steps we want it to run. So we're going to do that here in the train. So you can say input func, and you can say steps. So that's what we're going to have here. We'll say run it for 1,000 steps. So we're going to run that. It'll save it, and then you should eventually see the steps running. It gives you information. Remember, these aren't errors. It's essentially just reporting back what the final loss step is, etc., / the loss at each of these steps. So you can see here we start with a huge loss, 451, and very quickly we begin to die down. It may come up and down as you continue training. You can see here it kind of oscillates a little bit between 6 and 11, but eventually we get some sort of convergence to a loss here on our training set. So we're able to train the estimator. Now it's time to actually get some evaluation metrics, and the estimator API also has nice methods or convenience methods for that. So I will zoom in one more time here so we can see that. Let's go ahead and get the metrics on the training data. So the way I'm going to do that is I will say train underscore metrics, and then off of this estimator object, instead of saying like I did up here train, I'm going to say evaluate, and then I'm going to specify that my input function is now that train input function, and let's say steps is equal to 1,000. So the reason I want this train input function instead of this input function is because since I'm using this to evaluate, I specifically don't want to shuffle this. I want to make sure everything's in the same order. That way I can do the evaluation correctly and see how did it perform against the true label. So we're going to run that, get those train metrics. So depending on your computer, this may take a little bit of time. You should end up with some kind of huge output here. And if this output is bothering you, you can always click here on cell and say current output clear. Your results will still exist, but it will clear the output. So I'll go ahead and run that again and keep the output there and then scroll down a little bit. I have a pretty fast computer, so keep that in mind. Your results may not be as fast as mine. Next, what we're going to do is the exact same thing. We'll say eval metrics, essentially our test metrics. So we'll say estimator, evaluate, and then we'll say input function is equal to my eval input function. And then I'm going to say steps is equal to 1,000 here. Let's run that. Again, you kind of see this huge output, and once that's done running, what we can do is compare our results on the evaluation of our training data and our test data. We're going to scroll down here in order to do that, and what we're going to do is we're going to say print the train metrics. So that evaluation method we just did, or that evaluate method we just did, has a nice output, which is essentially like a dictionary. So I'm going to say training data metrics. Let's run that. And so we can see our loss, the average loss, and then global step, which was something we defined earlier. Now that I understand my training data metrics, I want to compare that to my test set or evaluation set metrics. So I will do the exact same thing here, except I will print out eval metrics, and then say print eval metrics. And this is a really nice way to check if your model is overfitting to your training data. A good indicator of your model being overfit to your training data is when you have a really low loss on your training data, but a really high loss on your eval data. We want these to be basically as close as possible to each other. That doesn't mean we want them both to be high. We want them both to be low, hopefully, but a good sign that you're not overfitting is that your training data loss is pretty similar to your test data loss. You should always expect your evaluation loss to perform slightly worse than your training data. Again, this really depends on your data, your random splits, how much data you gave to training versus how much you gave to test or evaluation, etc. Lots of specific factors for your specific situation, but in general, you kind of want these to be relatively similar and not way off from each other. If your training data metrics are much better than your evaluation or test data metrics, then you're probably overfitting to your training data. Okay, so we're almost done here, except a really common question when we're creating models is the question of, well, how do I predict new values? The metrics are nice, but let's say I actually want to deploy this thing. How do I get those new values, those predicted values? Well, let's show you. I'm going to create a new input function called input fn predict, and it's going to be tf estimator inputs, again, a NumPy input function, and I'm going to pass in test or new data here. So what does that actually mean? Well, let's say I have some new data of x. Remember, we're doing just a simple linear regression. So I'm going to say my brand new data to predict. So given some x value, what is its corresponding y label according to your model? So we're going to say my brand new data is np linspace 0, 10 points here. So these are 10 points that my model has never seen before, and they're conveniently linearly spaced. Again, you can kind of play around with these values here, but this is essentially brand new data. The model has never really seen these data points before. In a sense, it kind of has, depending on how you created our data, but we're going to pretend like it's never seen this before. So we have our input function to predict, and we're going to pass that in as x here, our brand new data. So brand new data. And then what we're also going to do here is say shuffle is false. So we'll say shuffle is equal to false. We'll run that. So now we have our input function to predict. So we're going to say estimator. And instead of saying train or evaluate, the final method I want to show you is the predict method, where you just pass in that input function predict. So the difference between this TF estimator input that we created versus the previous ones is here I'm passing in brand new data that I want to predict for. So let's go ahead and run this. And you'll notice it's a generator object, which means if I actually want to see the results, I need to either iterate through this, or conveniently I can cast it to a list, and then I'll see a list of all the predictions. And here we have it. It basically returns a list of dictionaries where the key is predictions, and we have some sort of array value as well as the data type that it is. So let's actually kind of plot these out and see how we did. So what we could do is say, we'll say predictions is equal to an empty list. This could also be an array. And then I'm going to say for pred in estimator dot predict. Actually, I'm just going to copy and paste it from here. So basically in that list, so for prediction created by this generator object, I'm going to say predictions, and I'm going to append pred predictions. The reason I'm doing this append operation here is because remember, each of these items is a dictionary, so I'm calling the predictions key, which is going to return that array value it predicted for it. And then I'm going to run that, and then we should be able to see a nice list of predictions. So great, there is my array. Let's actually plot these out and see how we did. So I will say my data, I'm going to sample n equal to 250 here, and let's go ahead and do a random scatter plot again, just like we did last time. So scatter, where x is equal to x data and y is equal to y. So remember, those are our samples here, and let's do a plot based off of our predictions. So I'm going to say np linspace. Actually, I can just pass in our brand new data that we had. So that brand new data plotted out our predictions, and then let's make it a red line. And you can see we have kind of the same linear fit we predicted last time, and we could even do the points themselves. So these are the points I predicted according to my model. You can see here it's essentially following that y equals mx plus b that we did earlier. So that is how you use the estimator object. Let's quickly do a review of everything we just did. And if it's still a little fuzzy to you, don't worry, we're going to do a classification example that uses a TF estimator API, and I think that's going to make it a lot clearer. This was pretty confusing to me personally when I first saw it, but once I went through a couple of examples, it became a lot clearer and the workflow became really clear. So we won't be using the estimator API beyond this section, not really. Instead, we're going to be using kind of the more thorough way with the placeholders, the variables, etc. But I do want you to be aware, in case you ever plan to use TensorFlow for simpler tasks such as regression and classification, the estimator API is really useful here. So really quick review, we have to create a list of feature columns, and every item in this list does a special feature column call, where either you have a numeric column, maybe you have a categorical column, and we'll show you how to create those later, and then you provide it with a key as well as a shape. Then you actually create your estimator. Later on we'll show you how to do more complicated estimators such as a dense neural network, classifier, or regressor. Then we do a train test split. You should really be doing this regardless of using TF estimator or not. Then we actually create some input functions. I create an input function based off my training data. Then I create two more input functions, one for my training data, one for my test data. And the main difference there is I'm telling it not to shuffle it. That way my evaluations are in order. Then I train the data on that first input function based off the training data. Once that's done, I can evaluate my train data metrics. I can also evaluate my eval metrics, which is basically going to calculate the loss function for me. So then it reports back the loss. This is a nice way to check for overfitting. If I ever want to predict off of new data points, I can just create a new input function for prediction where I pass in the data values I want to predict for, and then I can say shuffle is equal to false, and then I call estimator.predict, which remember is a generator object, so you need to either cast it as a list, or if you want, just iterate through it and then append the new results, and then we can plot them out, do a histogram, whatever you really want to do. Okay, hope that was interesting to you. Again, if you're a little fuzzy on this, don't worry, the classification example is going to clear it up even further. I'll see you there.